So oh, we're recording now, so that's good. Thank you for coming back to the second part. I thought with the weather being as beautiful as it is that there might just be me and Paul here, but you've all turned up, which is heartening. Probably before we start, what I'll probably do is just clarify some of the stuff. I mean, I'll tell you what, let me just do some sharing first. Need to do advanced content from this camera. This might not work initially. Let's see if we can. Not that one. That's the one. But yeah, sorry, I've just got to move this off this screen, otherwise you're going to get feedback. Let me just do that. Okay. So hopefully you can see me at the moment. If I do that, you should see my desktop. Good. Yes, I think that's the case. Yes, I'm using, so I've sort of got a bit more fancy since last time. I've got the ability to do all sorts of funky stuff now. So let me just move that. Oops. All right, so let's make a start. What I was going to say is that for those of you, I don't know whether everyone's faces I see were on the last presentation, but if you weren't, or you want to go back, I know that Andrew just asked about some information from the last lecture. If you go to the BA website, I think you have to have a log on, so you have to be a member to see this. But if you go to the radio astronomy section, BA RAG bit, there's a section on of events, and it's got upcoming events, and it's also got past events. So if you wind down here, you'll see that there's a link here to where you can watch the videos. I think are they on YouTube, Paul? I think they might be. So
yeah, they are on YouTube, and every mail I send out has got the link.
Oh, right. Okay. So you all know where that is. Well, that's all in there. There's also Paul Hard's excellent introduction to Spectrum Lab. For those of you that didn't attend that, I would recommend watching that, because that's another good tool which I use and like. So anyway, that's where you find the first one. The other thing to remember is that I've got a Git a repository with everything in it. So this is all of my Jupyter notebooks, as well as all of the code that we're working with and everything, and that can be found at BA. I think there's I did send a link out, but it's BA RAG Python workshop. I think if you search for that on Git, you'll probably find it. And if you need it, let me know and I'll send you a link. So if you do if you're conversant with Git, you'll know that you can just clone this repository, and you'll end up with all the material on your machine, and so Norman might not need to write down so much with his pen, because most of it's going to be you're going to be able to find it on here as well.
Ru, sorry, can I just interrupt you a moment?
Sure.
We've got a bit of a timing difference between your audio and video.
Oh, really? That's good news.
I think it's about half a second. It's quite.
Oh, really? That bad?
It's quite. Yeah.
Ah, that's.
Oh, Callum is reporting it's okay for him. How interesting.
Oh, maybe it's just you.
Tony,
it was me
that
raised it. I was checking what I asked everybody else if they were seeing similar.
Yeah, I'm seeing a bit of a lag.
Are you? Well,
we'll get used to it. We'll just to
be honest,
ignore your face.
To be honest, I'm going to go. Oh, actually, were you looking at the screen? Were you looking at me? Yeah. I mean, to be honest, you're going to be looking at the screen most of the time. So as long as that's sort of real time, it seems to be.
No, that's better. You're in sync. You're in sync now.
Oh, well, I haven't done anything, so it must have been a Zoom thing, wasn't it?
So you're yeah, but I can't see you.
Ah, right, okay. Well, you can, if I do that, you should be able to see me. There you go. I've actually.
And now you're out of yeah.
So that's out of sync, is it? Sorry, you muted.
Yes,
Andrew.
yes, it is.
Oh, right. Okay. Well, you don't need to see me. I'll turn me off. It's not that important.
We get used to it anyway. It's
Yeah.
not-
I'm using a product which some of you may be familiar with called Obs Studio, which is like a broadcast product which allows you to have multiple cameras and screens and such like, and it does make life a lot easier when you're doing Zoom, but and it normally doesn't do this, and I don't know why. I must have set it up slightly wrong. It's a fiendishly complicated, as all these things are, of course. Anyway, hopefully you can hear me and you can see what I've got on screen, which is more to the point. So anyway, you can go there and get all this information. So let's get back to, I think where we left off was I'm going to go, where shall I go? Where we left off is we did a very simple logging program for Raspberry Pi Pico. So I thought we would go back and have a little quick look at the Raspberry Pi. Let me just get my screen sorted out. Oh, that's it. Right, good. We'll have a look at the Raspberry Pi Pico. So let's just bring up. I think I've got a Jupyter notebook here somewhere. Sorry, I should have had this ready. I think it's this one here. I think we ended up on this, which was me explaining about the Raspberry Pi Pico having an AD converter in it, which could be used for sampling as an SDR. And in fact, this is a project here, which I think I showed you, which is somebody has actually written in C. This is an Arduino program which you can upload to the Raspberry Pi Pico, and then you can connect it as an SDR. So it works with all the SDR software. I think that's what we're going to be doing in a few weeks, isn't it? That's the new radio. So that's an interesting project in its own right, and it's something that I'm going to have a play with as well. Interesting things that have happened on the Raspberry Pi front in the last few weeks since we last met. The most notably, I'd say, is the introduction. A lot of people are now getting access to the chip. This is the Raspberry. You can see on there. You can see the Raspberry Pi logo. This is the Raspberry Pi 2040 microcontroller, and of course they've sent it out to everybody now. This is actually quite a killer little product, which is this is the actual Arduino release of the Raspberry Pi microcontroller, and it's actually quite an interesting product. So it's a little bit more expensive. In fact, I've put a link in the Jupyter notebook, which so it takes you to this. In fact, let's go and have a quick look. As you can see, it's a little bit more expensive than the Pi. The Pi is only like £4, which makes it fantastic. You can literally litter them everywhere. I've done about 3 projects with them so far, and they're working great. And all the Python I've written, is running really reliably, and I'm enjoying them a lot. But this is a little bit more expensive, €21. So you have to put, but it has a lot more stuff. It has got, in fact, for the Eagle Eye, you can see there's a radio module on there. It has, what has it got? It's got 802.11b GNN, so it's got Wi-Fi connectivity. It's got Bluetooth as well as low energy Bluetooth 4.2, which again is great for connecting to some certain bits and pieces. It's got a built-in microphone and microphone preamp, and it even comes with an AI license for doing voice recognition. So interesting. It's got a 6-axis IMU on it, and it's got things like fall sensing and double tap, which I don't quite know what you'd use that for, but it sounds interesting. Fall sensing sounds interesting too. I don't know what you'd use it for, but it could be handy. So it's quite innovative, I'd say. It's got the usual 22 digital pins, 20 of which can be PWM. It says they're 8 analog. That means 8 analog pins. It's only got 4 A to D converters on it, so it just means that it's available on 8 different pins. It hasn't got 8 A to D converters. That's my interpretation of that one. So just don't fall for that, thinking you're going to get 8. Unless I might be wrong, but that's what it says. Now, the nice thing about it is that you can program it either in Arduino. So if you like or need C for whatever reason, then you can. But also there's a MicroPython build for it as well. So you can program it entirely in Python, which is the reason why I'm telling you about it. Which is a very quick way of getting things up and running. At the moment, MicroPython and the support for some of these boards is not as deep as the Arduino. I mean, Arduino is very, very, what's the word? There's a lot of stuff available for Arduino, but of course, you have the downside is you have to write everything in C, which it's not always the quickest way of getting things done. But sometimes, you need to do it. Even I will write in C if I have to, but I do prefer Python just because of its speed and just easier. So anyway, that's happened since we've since the last meeting, which is interesting stuff. What we're going to work on next is we're going to stick with the Raspberry Pi Pico for the first little project. What I thought we'd do, I'm just going to bring up the this image again. As you can see, I'm just working in Visual Studio here. So this is my Git project, which I've imported in here. In fact, it's all been done through Visual Studio. As you know, this is my sort of preferred environment, really, because it's flexible and it can do things like show images and it can show Jupyter notebooks and obviously code, and it has all the terminals built in, so it's quite a nice environment. This is a Fritzing diagram of what we've actually got on the desk. I've got on the desk in front of me, which is a Raspberry Pi Pico. And what we did last time is we read the values from this pot, just as something to read. So we're just using the A to D converter, twiddled the pot, and we stored some values on board. Oh, I don't know if you noticed on the Arduino Pico, if you want to call it that. I think it's called the Nano Connect. On the Nano Connect, they've actually got 16 megabyte of SD on the board as well, which is really nice. So whereas with one of these, if you want to use more memory than the, I think it's got one on it. If you want to use more than that, then you have to use an external SD card. I mean, they're not expensive. The little readers are only a couple of quid from German Mouse Poundland, but if it's built onto the board, it's a lot easier. So having 16 meg is pretty useful for logging. You can log an awful lot of VLF or whatever on 16 megabytes. So that could be handy for a hilltop logger. So what we're going to do this morning is we're going to have a quick look at this motor. I thought we'd do a little bit of motor control just for those of you that wanting to do things like antenna rotators or telescope control, or there's all sorts of things that you can do with motors, and I thought I'd show you how simple it is to work with a motor. I'm also going to show you how to do serial control, because again that can be very handy to interface to other devices, either devices you're controlling or being controlled from another device. And what we're going to do is connect a PC using a serial port, which actually we're going to be using a USB to serial adapter, or a little FTDI board. Again, these are pennies from China, and then you can talk to your Raspberry Pi Pico from a PC. So we're actually going to write a GUI on the PC using Python to control our motor. So that's the ultimate goal. So I thought I'd put that little exercise together just to. So the actual real device is here. So if I can show you that, this is on the desk in front of me there. I've got, as you can see, that we've got. Let me just move the camera slightly. We've got the Raspberry Pi Pico. There's my button. That's the pot, which we're not going to be using. We used that last time. This is the little H-bridge controller, again, sort of China Poundland special. And then I've just got a small motor and gearbox with a 3D printed arrow on it to show what could be an antenna or something like that. And we're just going to rotate that around. So the first thing we're going to do is just do a very simple implementation to get this button here moving the motor, just to show you how you can have a local physical. Can't quite see that, can you, from there? But there, a local physical button. It's just a little PCB mount button on there to spin this round. So if you wanted some physical proper buttons, you can. It's easy. And then we'll go ahead and do a GUI on our PC to control it. So that's the goal. So the way that I am connecting to my Raspberry Pi is using the, I'm just recapping now, so that if you've forgotten how this all works. If in Visual Studio, if you go to the extensions section, which is here, if you click on the, sorry, if we go to there's a set of sort of little blocks here at the left-hand side in Visual Studio, and it's where all the extensions are. And in the extensions, I'm using this Pico Go plugin here, and Pico Go plugin allows you to interface directly to your Raspberry Pi, Pico, or any of these MicroPython type boards. So that's how I'm actually attaching to it. And what it does is it puts in a you'll see at the bottom here, there's in fact over on the right here, you'll see it says Pico Console. So I've actually got PowerShell and Pico Console, and we'll have some others in a minute when we start controlling other things. But the Pico Console is part of the Pico Go library or extension. And what it does is it allows, you can see it here, it's actually connected using the USB port to the Raspberry Pi Pico. And on the Pico, on all MicroPython devices, you get the REPL, which is the, I can say print, I can go in here and say print hello, BAA rag, and it will execute that command. So you've got the direct control on there, which is really, really quite handy. For instance, well, you can see I was sort of practicing this last night just to show you some of the basics. If you want to actually physically do things on the device itself, you can actually just type in raw commands into the REPL to test them. So if you the actual in fact I've got such a lot in there actually, but yeah, that's why I've cleared them out. If you want to, for instance, have a look at the state of the button, well, we're going to start with the button. So the button itself that you saw, let me just do that. This button here on the interface is wired into pin 16 on the Raspberry Pi Pico. If you want to see what the pins look like, one of the nice things on here is that when you've got Pico Go running, you can click on here and you've got show the pin map. So you can actually see the pin map here. So the button is plugged into this connector here, which is the very last one on the bottom. I always pick the ones that are near the end so you can count your way to them. That's one of the downsides of the Pico actually, is that the silk screening for these pins is actually on the bottom, which is a bit of a, I think, something that they hopefully will change in subsequent releases of this product. Whereas the other manufacturers have already cottoned onto that and they've silk screened them on the top, which is more helpful. But the button's connected to this pin 16, so we can go ahead down here and we can actually type that in. So what we need is there's a library built into the Pico, which is called Machine, which contains all of the. In fact, if you want to see what's in there, you can say help machine like that, and it will show you all of the classes that are actually in the device, which is quite handy because you know, the physical device, the firmware that's on the device, locally you don't really have a notion of what's on there. So if you want to, if you do help machine on there, if you do that on any MicroPython device, it's going to show you all of the stuff that's in the firmware running on there. So you can see that there's a whole bunch of stuff in there. And the one we're interested in is this pin, which is going to get us access to that button, the pin itself. So what I'm going to do is say from machine, which is that library. I only want pin. I'm going to say import pin. It's a capital P. If you look, just that's worth doing the help just to find out what the because as you know, Python is case sensitive. So if I did lowercase p, it would say, oh, I don't know what that is. So when anything works, like in Linux, when anything works, it just comes back with a prompt. You don't get it has worked. That's for the reserve of Windows users is that one, confirmation of positive confirmation. You only get negative confirmation in these geeky environments for some reason. I think it's supposed to be a sort of an insult to your intelligence to confirm something that you know is going to work. It's a sort of arrogance of programmers or something. So from machine import pin. So we now have a pin available to us. So we can now assign our button to a pin. If I call the button but, I'm going to say but equals. So we're going to create what's called a namespace. A namespace is just a named object, basically. They're called namespaces, but it's just, or a lot of people use the word variable, but it's a unique object which has a word which doesn't clash with any of the other words, but it's our own word. So but is what I'm going to call button for the purpose of what we're doing here. And it is a pin, so we're going to invoke the pin class. And I'm going to say it's pin 16, which is where I've got it wired to. And I'm going to say it's an input. So I'm going to, because obviously these pins can be inputs or outputs. There's lots of choices here. So it's pin.in. So that's a constant, which is available in the library as well. So pin.in is how I tell it, the class, when I instantiate the class, how I tell it that I want pin 16 to be an input pin. I also want to, the way that I've wired it is that I've got the switch wired to ground. So I want the pin to be basically sitting high. And when I press the button, I want it to pull that pin low. And in order to do that, I'm going to need a pull-up resistor. Now you can put your own pull-up resistor in to the positive rail, or the chip itself has built-in pull-up and pull-down resistors. So it saves you having to use physical resistors. They're actually built onto the silicon. But you have to specify whether you want pull up or pull down. So I'm going to say pull, which is the command which says where I want my pull to be, and I'm going to say equals, and again it's a constant, so it's pin dot, and in this case it's pull up. So that's the syntax for I want to use a pull-up resistor. So that's if we've got that right, when we hit return again, we just get the prompt. So that's now instigated. If you want to just check that, you can type but and hit return, and it will just tell you what it is. So it'll say this object is this. So it's a pin on pin 16. It's an input pin, and it's using the pull-up resistor. So that means now that whenever I press the button, we should see it go low. When we're not pressing the button, we should see it high. So all I have to do now is do but dot value. Now this is a method. Value is a method which returns the value of the button. And when I say it's a method, what I mean is that it's like a function. So you have to put the parentheses on the end of it. That's a standard Python protocol. If it were an attribute, I wouldn't need the bracket, the parentheses, but because it's a method or a function. But functions within class objects are called methods. That's how the terminology works there. So if I do but.value, it should be 1, which is right because I'm not pressing it. So if I go ahead and press this, which and I do dot value again. Unfortunately, it doesn't repeat its last command, which would be nice. You get 0. There you go. So we can detect the state of the button. Now you can also do something like while true. We can write a loop. So if we say while true, this is an infinite loop, is while true. That's how you do infinite loops. So if I do while true, and I then say but dot value in there. Okay. Now this is going to obviously go crazy. There we go. And then if I press I'm pressing the button now. There you go. It's gone to 0. If I let go back to 1. 0, 1, 0, 1, 0. There you go. It's going absolutely mental because it's looping around really fast. What I should have done is do import time, micro time, and then I could have done while true, just improving this one, while true, and then I can do but value. And underneath there, I can do u time dot
Sleep.
U sleep, or is it sleep on its own? I think it's just sleep. Hang on. Yes, it is just sleep. So if I can make it sleep for, let me do 0.1 of a second. So no, that's going to do 10 at 10. Let's do 0.5. So every half a second. So if I now hit that, so now it's doing it every half a second. Oh, not quite. There we go. There you go. So you can see it's not quite so frantic now. So I'm detecting the input of the button. So all this can be done on the REPL, on the on this command line interface here. So it makes life when you're experimenting, when you first wiring things up, it's quite useful. Now, of course, we want to write a program that does that's a bit more sophisticated. So that's what we're going to go ahead and do. So all we need to do in here is create a new file. So let's have a new file, and we will we'll say let's give it a title. So we'll say this can be motor control, or a motor control. Oops. Now we just need to save that. So if we do save as the P code, yes, that's where we want it. We want to do RA. Do it. So we've now got our Python file. Let me just double check there. There we go. I've spelt it with a slightly weird spelling, but we won't worry too much about that. But this is our motor control program. So what we're going to do is type something fairly similar into here to get us started. So I'm going to start with the same line of code, which is from machine import pin. So that gets us our pin class. I'm also going to import time. You can use time or micro time. I think I don't know whether it's the same library. Actually, you might have to check. But there are two versions in here. There's U time and time. I think U time has some additional features, but I'll just do time for the sake of it. And then from machine, I also want to import UART, because we're going to have an RS-232 connection, if you remember, and I'm also going to be using the pulse width modulation of the device as well, because I want to control the motor. That should say import in there. So the first thing I'm going to do is just print something out. I always do this because it allows us to Pico motor. The reason I do that is because when we get to the point where we want to run it, we come down here and we hit this run button. It'll run in here, and I know it's running because it's going to print Pico motor control. So it's a good way of seeing whether it's actually you know, sort of made it into the Pico, and you know, it's got a chance of actually working. So I'm also then going to program in my but command, the same one as we did down below. So this is exactly the same. So if you remember, we're invoking the pin. Now the nice thing once you're in Visual Studio, of course, is that you get all the IntelliSense stuff. So it automatically jumps to pin and says, "Oh, I know what you're talking about." It shows you that a pin is the basic object to control I/O pins. You can go in here, and some of these you can scroll down, and there's not this one, but there's more information that you can dig into. But this is all the stuff that's available from the help. You can go in here and type help, and all this will come up as well. But it shows you, and hopefully when I do the parentheses, it should now tell us all of the objects. So you can see now, there's my mode with in or out, and pull with pull up, or it only shows you. It's annoying it doesn't show you all the alternatives as well, but it does give you at least an indication of the objects that are available to us. So we're going to do pin 16 is the pin number that we're doing. If you remember, and we're going to say pin dot in for our input, and we're going to say pull equals pin dot. Did it before, there we go. So that's our button programmed in. So let's go ahead and add something similar to what we had before, which was while true. So that's an infinite loop, and I'll make this a little bit a bit slicker. I'm going to say if but dot value to 0. Now don't forget that when you're doing Boolean comparisons, you have to use double equals. That's something that when you first start, you'll fall into the trap of using equals, and of course that's an assignment. So it will actually cause an exception in this case, but sometimes you can use an equals instead of a double equals, and then you end up with very odd results because it becomes an assignment rather than a comparison. Whether it's a double equals, it's a Boolean comparison. So it's saying, is the value returned by but.value, or that method is going to return a value, does that equate to the same as my constant, which is in this case the 0? If it does, then it's true, and it will do the following command. And I think what we're going to do is just have a print in there, and I'll just say button. So that's what we're going to have in there. And if at the moment, I don't think we need anything else, that should do it. Now, in order to stop this going like, well, actually, it doesn't matter if this goes like crazy, to be honest, because it's just going to test for that. So we'll only ever see that if the button is pressed, we'll only ever see it printed out when we press the actual button. So we can go ahead and run this now just to make sure that everything's in order. I always like to, when I'm starting a program, sort of build it, because that's one of the beauties of Python, is that it's not like C, where you have to compile it and upload it and then wait for it to reboot and all those other things. I mean, okay, a program this big doesn't take that long to do all those things in C, but as your program gets bigger, that can be the case. But the nice thing is here, all I have to do is come down here and hit the run button, and we should see this run. So what we should see is it's print out, it should print my Pico motor control, which it has. So now it's running. I can come along and press my button, and you can see that, well, there you go. We do need to have a delay in it, because of course when the button is 0, it's going to just constantly print that out. So we can just enhance that slightly by in here saying time.sleep. We'll do something like that. What do we do before 2, didn't we? So if I now come down here and do stop and do run again, it's now running again, and I can now test it with my button. That's better. So I can press my button. You should be able to hear me pressing it and see it appearing on the screen. So our basic program is now up, running and working. So far, so good. Now, what I want to do is control our motor. So in order to do that, we're going to use this UART command. Sorry, no, we're not. We're going to use the PWM command to actually control the speed of the motor. So I am going to do a couple of things. Let me just quickly go back to the picture of my, I think it's that one there. The way that this board works, just very quickly, I'm going to explain. It's got 3 connectors to the Pi, you can see here. One of them is forwards, the other one is reverse, and the other one is an enable pin. And the way that the data sheet for this chip says you should use it is that if you want to be able to change the speed of the motor, what you do is that you wiggle the enable line. So every time you enable it, it obviously puts power in on the direction of whichever pin you've got set. So if you have forward high and reverse low, and you send a pulse down here, it will pulse the motor in the forward direction. So if you then send a stream of pulses down here, it will obviously then increase the speed of the motor. So we're going to put a PWM, a pulse width modulated signal, down this enable pin, which will activate the motor in whichever direction we have the other 2 pins set. Does that make sense? So what we need is 3 pins specifying, one for the forward, one for reverse, and the other one for enable, which is the name that they give this one on the board. So I called it the same thing. So we go back to our program. So underneath my button, I'm going to create one called EN, which is my enable pin, and this is the one that we're going to send out the pulse width modulated signal. So this is PWM, and the pin I've connected to is pin 15. Oops, not 115, not got that many pins. So that just means that from now on, all the pulse width modulation commands that I'm going to send it are going to go out of pin 15. I then need the 2 other pins, which are forward and reverse. I'm going to call those, so not surprisingly, forward. And this one is going to be its pin again, because this is just a straightforward output pin. So pin 14 is the one I've used. And of course, we need to tell it what mode it is. So is it an input or an output? And in this case, it's pin.out. And then we also need reverse, which is pretty much a copy of the, so we can just copy that line and change that to reverse. Oops. Okay, rev. And it's pin 13 instead of 14. It's the reverse pin. So there's my 3 pins. So now I can actually control the motor using those 3 pins. I'm going to, am I going to create a speed? Yeah, let's I'm going to have a variable called speed, and in fact I'm going to call it set speed, and I've played around with this, and the value I'm going to pick is 30,000. The value of the PWM output is 0 to 65,535, which gives you the duty cycle of the output. So 65,000 is basically permanently on, and 30,000, which is what we've chosen, is about 50% duty cycle. It's 32,000. I can't remember what half of 64,535 is, but it's you can work it out. So that's my speed. that I'm going to actually use in for this. Now I'm going to define a function here to control my motor, just because we can, and it's good practice to show you at least some basically good programming practice. So I'm going to create a function called motor, and it's going to have two parameters, and I'm going to have direction and I'm going to have speed. So this is an attempt to try and abstract now this piece of code so that it makes it reusable, because in a program like this you're probably going to end up with a fair degree of times when you want to control the motor. So rather than having to put these dedicated commands in every single time and having them repeated all over your program, if you write a function which accepts the basic information that you need, you can put the complex code in there just once, and then you've got less to maintain, it's more reliable, and your code just is much more manageable in that way. So this is always a good practice for those of you that aren't terribly familiar with programming. So I'm going to say if direction is forward, so I'm going to have a command called fwd, which is just a string. So that's when you put something in single quotes like that, it's just a fixed string. So I'm going to have a command called forward, which I'm going to pass into my attribute, to my parameter called direction. When I call this, if it's forward, then what I'm going to say is fwd dot high. Now this is how I send this forward pin here, pin 14, how I make it go on or high. You can, there's all sorts of there's different values you can send to it, but you can see here it's a method, and I'm making it go high. So that's going to effectively tell that motor board to move my motor in a forward direction. That's basically all that's doing. I've also got to say reverse pin, I've got to make that go low, because that's how the logic of this board works. So you have to pull the forward high and the reverse low, and then it'll move in the forward direction. If you put both high, it's dynamic braking. If you put both low, it's sort of don't know what happens actually. It's just sort of, it's just free then. You can then move the motor. Although I've got a worm gearbox on my motor, so it doesn't back turn anyway, but if it were a free motor, it would move backwards as well. So then I'm going to have an elif, which is what happens if the first condition is not true. It'll move down here and we'll do an elif, and I'm going to say if elif direction is reverse, surprisingly, which is the opposite of my my forward command. This forward and reverse command are just arbitrary. They're going to be passed into my parameter there, that direction parameter. So that's where I've got those from. So this is exactly the same, but in the other direction. So it's going to be forward dot low and reverse dot high. So that should set our motor up in order to move. Now, the one thing we haven't done yet is actually enable that, send the enable pin, and we're going to do that with our pulse width modulation. So every time we receive a command, every time we receive a motor command, we're going to have a direction, we're going to have a speed. So here we want to say EN, which is our enable pin, if you remember. In fact, it's telling us on our IntelliSense, look, it's a PWM pin. And if I do dot, it'll show me all the things I can do. And there's as you can see, a number of them. The one I want is this one here, duty U16. So this is a 16-bit duty cycle value. If you remember, I've already chosen a speed up here, but for this one, so I'm going to hit enter there, which is my duty cycle U16, but I'm going to make it equal to speed, which is this parameter variable here. So that means I can call this now. I can call this function from my program down here, and I can say which way I want it to go and what speed I want it to run at. That's basically what's happening here. So let's go ahead and do that. there's one last thing I need to do is I also need to set my PWM frequency, because that is settable. So I'm going to do en.frec, which is, as it says here, this is the frequency of the pulse width modulation. So that's the rate at which the noughts and ones are going to come out of that pin. And I found that 500 Hertz works quite well on this motor. You have to play around with it on different motors, and different motors have a different capability, and sometimes they'll whine and groan if you put the frequency wrong, because you know, it sort of resonates. Going back to oscillation again and amplifiers, it's probably all mixed up with the same thing there. Yeah, if you can pick some values, and the motor you'll hear that in badly set up motor drive systems. You'll hear the motors going like this, you know, and that's usually because somebody hasn't set these PWM frequencies properly. They haven't tuned them to the motor itself. You can play with that yourself if you get some motors and some boards like this, and you'll see what I mean. So let's go back to our button. At the moment, we're just saying somebody's pressed the button. We're not particularly interested in the button being pressed now. We know that actually works. But what we are going to do is we're going to call our function that we've just created. So I'm going to say motor, which is the function itself. We've got to pass the two parameters. So in this case, I'm going to say go forward, and I've also got to have a speed. So I'm going to say we'll do it set speed. But we'll just type in a value here just to keep it simple. So if I do 30,000, it should go about half the speed for this particular motor. Now, one thing that if I leave it like this piece of code, what will happen is that when I press the button, it'll send the PWM to a 50% duty cycle, and the motor will spin at half the speed, which is great. But what I think I would rather have is when I let go of the button, that the motor stops. So in order to do that, what I'm going to do is put an else in here. So if I do else in there, what that means is that when the button isn't pressed, so when in this case when we let go of the button, I'm going to send another command, which is motor, and I'm going to say FWD. So I'm going to send it forward, but I'm going to send it forward at 0 speed, which means that the pulse width. I'm not going to keep saying that because I'm just wearing these teeth in for the dog, so can't say it very easily. PWM. So this makes the PWM go down to 0, and then it stops the motor. So this should be all we need. Let's just double check. We're going to press the button. We're going to send the motor to 30,000, which is half speed. If the button isn't pressed, it's going to send a stop. So theoretically, our motor, this jobby here, let me just move that into shot a bit better. Hang on a minute, let me just move these around so we can see what's going on there. And where's my button? You can see my button there. There's my button, and there's my motor. So, and the motor control, although the motor control doesn't do anything other than drive the motor. So if we come down here to our program and we say run, we should see the command come up once it finally decides to. There you go, Pico motor control. If I go to my button and press my button, hey, the motor goes round. There we go. Now when I let go, it stops. Start, stop. There you go. So that's pretty simple to get a motor, speed controlled motor going. Excuse the noise of my wife hoovering. Let me just shut the door. She's not gardening, at least. So that's a really simple way of getting the motor working from here. Now, you know, if this were like a rotator or something like that, then you probably, I mean, having buttons like that is really all well and good, but it'd be nice to actually do it from your computer. Sometimes, you know, you want to be able to manipulate devices on the roof or whatever. Those of you who've got, you know, nice shacks with antennas all over the tops with rotators on them, or dishes with motors, then that's all good fun. So what we're going to go and do is we might not be doing something like this, but you know, this is actually the Gemini telescope. You can see a picture of it in the background. But what you'll notice in here is that these control panels, some of these are about controlling the actual telescope itself. But when you actually look at this code that's running on here, what you'll find is that this is actually all written in. This is all Python with Python GUIs on top. Probably looking at it, it's a Python GUI library called tkinter. So this is the stuff we're just about to write. So what we're going to end up with is like a miniature version of the Gemini Telescope Control Center. Do you like the way that I've extrapolated that to turning my little motor around and around? And but these guys are only doing the same stuff as we are here. Obviously, what they're controlling is a you know, an 800-ton telescope. It's slightly more responsibility there than turning a 3D printed plastic arrow. But nevertheless, that's what we're attempting to do here. So what we're going to be using now, GUIs in Python, as you would imagine, Python is all about being quick and easy. And by far, there are lots and lots of different libraries you can choose in Python to create GUIs. And I've played with them all. They've all got strengths and weaknesses, but by far the easiest and simplest for you guys to get started on. And in fact, it's my go-to GUI these days for putting together prototypes and whatever. There's a library which I'm going to take you to it on the internet because and it's called Simple Gui. And it's very clever because Simple Gui, which is exactly what it says on the tin, is a simplified version of all of these other libraries. Now, what do I mean by that? Well, some of you have probably heard of some of these. There's TK. TK is the one that you're probably looking at on the Gemini telescope. tkinter it actually is installed with every version of Python, and that's one of its attractions. It means that you don't have to import any special libraries in order to make TK work. Qt is the other one, and now Qt is there is an open source version of Qt, but there's also a professional version which you have to pay for. Now, if you want to do professional level GUIs, then Qt is the way to go. I use Qt at work. Qt is multi-platform. All of these, actually, they're not all multi-platform. We'll come back to that. Qt is but it does look really nice on a Mac. It looks really nice on Linux. It looks really nice on Windows. Whereas TK is a bit more clunky. The nice thing about TK is it comes with everything. Qt, you have to install libraries, and sometimes you have to pay for features. So if you want to have real professional stuff, then you've got to put your hand in your pocket. WX Python is quite a nice library, but it only works on Windows, which, if you're a Windows user, is no big deal. So what WX Python has is it has a much more of a Windows look. So if you're sort of upset by that that rudimentary Gemini telescope type look, then WX Python might be the library for you. Now, what Simple Gui does is it wraps around all of these, so you can use any of them. In its default working method, which is what we're going to use this morning, it uses TK, and I've done that because TK is installed with Python as standard, so there's no need to do anything, to install anything to use TK, to use Simple Gui with TK. So it's very simple. The documentation for Simple Gui is absolutely amazing. I mean, it's just endless. There's so many examples and how to do things. It's by far the nicest in that respect, I think, as well. And considering it's like a one-man effort, I think there's a team of open source guys doing it now, but it's only been around for a couple of years. And I first came and found it sort of about 18 months ago when it was fairly new, and it really has taken off. And the reason is because it's supremely simple approach. What, let me just, I have a link somewhere. Where did I leave that link? I think it's in my, oh, I know where it is. It's in here. Excuse me a minute while I just get my program up. There we go. That's the link there. So this is inside the documentation, of course, there's of which there is lots. This is probably a good place to start. The window designer, I think it's quite comical. The window designer, as you can see here, compared to most GUI design tools, it's a little bit primitive, but the funny part of it is that there's no need for it to be any more complicated than a pencil. It's actually quite a nice looking pencil. So let's just have a look at a very simple example. This is the GUI that we're going to create. Well, I'm very quickly going to show you this GUI just as to cut our teeth, and then we'll put our own GUI together, which is going to be the GUI that controls our motor. So, you know, get a pencil, draw a box, put some widgets on. These are called widgets. If you're not aware, widgets are just things, GUI things that do things, and they're affectionately known as widgets. So you just put your widgets on there. So this is basically all you need to know about Simple Gui is this layout thing. So the way that everything is laid out is in rows. So this widget here is on row 1, this is on row 2, this is on row 3. So once we've worked out where our widgets are, what row they're on, all we then have to do is decide what sort of widgets they need to be. So this is just a piece of text, so it's a text widget. This is going to allow us to input a number, so that's going to be an input widget, and this is a button, which is called a button widget. So as you can see, there's nothing really difficult to get your head wrapped around here. Now, once we have our layout, all that we do to make our layout is that we create a namespace called layout. Layout represents our collection of widgets, and that collection of widgets is just a list. And a list is designated with a pair of square brackets, as you know. And within that list are each of our rows. So each row is also a list, because a row can have more than one widget. We haven't seen that yet, but we'll see that fairly quickly. This particular layout only has one widget on each row. So what we have are 3 lists inside a list, and each of the lists is a row. And so this row is the text widget, the next row is the input widget, and the next one is the button widget. Okay, so that's how the layout works. Now, the last thing we need to know is that we need a window. If you look at the, this is a slightly more advanced version, but you'll see that there's a window around the layout. So we also have to say what the window is. So again, we have a namespace called window, and it's designated as SG window, and we can put the words that we want to see at the top. And then we tell it what is inside the window, which in this case is our layout. So that's all the code you need to basically create and pop up this GUI. Now, inside this particular GUI, we have an object which is a button. This is our button object here, the OK button object. So we need to be able to read when somebody clicks that button. Everything in Simple Gui is event driven, and the way that the events work is that we can read the window, and the window will return events. Now in this instance there's only one button, so we only have one read value. This would typically be in a while loop, so you want to be constantly reading from the window. This is only going to fire once, but effectively what happens is that you're going to read the value from the window, and whenever there's an event, this will pass back that value as an event. It comes back as a tuple. So if we just saw the results from this, it would be a pair of values in brackets. In order to if you get past a tuple, you can what's called unpack a tuple by actually assigning two values at this side here. So rather than having one name equals, if I had one name in there equals window.read, I would end up inside that variable there, I would end up with a tuple. But I actually wanted two separate values, one for the event and one that contains the actual the object where the event came from. So I'm going to unpack my tuple by using these two values. So whenever you see two values equal to some function or other, it's because it returns something other than just one value. It's going to return, in this case, two values. All we're going to do is close that window and then pop up another window, which gives you the results of what happened. So again, SG, in this case, look, you can see import Pi Simple Gui as SG. So that's a pretty much a standard in Simple Gui, is that you rename the import SG just to make it simpler when you're typing these things in. So SG.popup is how you get a pop-up window pop-up, and we can put some values into it. So what I'm going to do is just put this into a program myself. In fact, I think I've already got it, so we don't need to sit and type it in. Pi Simple Gui example, there we go. So this is exactly the same as the example you just seen. It imports the library as SG. You will have to install this library on your machine using pip or something similar. But what we've got here is we've got a text box, which is going to say enter a number. We're going to have a box to put that number in, and we're going to have an OK button, which is a standard object, is the OK button. That's why it's called sg.ok. The values will be dumped into here, which we will then pop up and show on here. Now, to run this, I mean, anybody that's done any GUI programming in other languages and on Windows will know that this is supremely simple as far as GUI is concerned. Now, up in the top right-hand corner of Visual Studio Code, you can see it says run the Python code in the file terminal. So if I click this now, this will run this program. So hopefully, when I click it, we should get a GUI come up. There we go. So there's our GUI. So we've now got a window. This is a proper Windows GUI. It's got the minimize and kill. There's our enter a number. I can go in here. I can type a number in, say 25. I can hit OK, and it pops up another window, which is this pop-up here, and says OK and 25. So that's the value of event and values. So we can see those in there. You could print those out here as well if you wanted. You could say in here, you could say print event. Values, isn't it? Values. Oops, no, it's not. It is, but not equals. So you could do a print in there as well. Let's run it again just to see it again for those of you that blinked. So 45 this time. So if I do, and watch at the bottom down here now, you should see it printed out as well. There you go. So what you can see from that is that what you're getting out is actually a little bit more complex than we first said. You're getting OK, which is the button ID, and then values is actually a dictionary. And the dictionary has, because the return value from a widget can contain several pieces of information, and those are generally returned as dictionaries. You can tell it's a dictionary because of the braces around the ends here. So that's why we've got this line of code here where it says value 0, because 0 is that value there, which is the key. Dictionaries have a key and a value. So the value is 45, and that's what we were interested in. If we missed that out there, we'd have had the same thing in our pop-up. If we run it again, we would have had, if I do 78 this time, what the hell, living dangerously. You can see that we get a dictionary, and we didn't really want a dictionary. So that's why we had that's what the square brackets were doing in there for those of you that were wondering. So we've got value 0 in there, and then that way. Oops, I think we've still got that running. Run it again, and we go back to where we were. Any questions about that? It's I think you couldn't really get much easier than this. So all we have to do is work out our rows and what widgets we have on our rows, and then we can have a GUI. So let me just start by showing you the GUI we're going to design. I think that probably makes most sense. What time are we on? 10:30. Do we want to stop for a 5-minute coffee break, or do you want to continue on? What's the consensus on that one? Anybody?
5 minutes would be useful.
Yeah, okay, let's do that. Let's have a 5. We'll see you back here at 1:45, and then we'll do this GUI. I'll pop the GUI up and show you what we're going to do, and then we'll get it working our motor. All right.
Okay.
All right, here we go.
Just before we get started, could I
Yeah.
just ask a question?
Yeah, of course you can.
With the layout, that's I agree, absolutely brilliant way of doing a GUI. How do you get more than one item on a row? Is it just
We're
like...
just about to do that. It's
Oh,
just
right, okay. I'll hold.
yeah, well, it's there. It's a list again. It's a list of objects.
Yeah.
Each row is a list, and you can have any number of widgets in that list, which is your rows, your columns. Sorry.
Yeah.
And then each row is represented by a list. So yeah. It's
It's
really stunningly simple.
It's brilliant. Yeah. I struggle slightly with all of this object-oriented stuff because I was brought up with Fortran Basic and Z8.
Well, I was as well, and funny enough, I mean, I've been programming in C languages, C and derivatives for years, and C++ always was a bit of a, to use an expression, a bit of a mind bender for me.
Yeah.
Because I couldn't get to grips with the object-oriented, and it wasn't until I learned Python that the whole thing, the penny dropped.
Yeah.
And once you get it, it's super clever and powerful.
Yeah. My son did A-level computing, and he was talking about methods and dictionaries and stuff like that. And I thought I haven't a clue what you're talking about. He was doing C#.
Yeah, well, C# is Microsoft's answer to Python, basically.
Yeah.
It's not the same. It's different. Yeah, it's a language I'd quite like to learn because it seems to be becoming quite popular, and it does have some advantages. They all have pluses and minuses, and the more languages you learn, the more versatile it makes you. That's for sure. But there's nothing wrong with starting with, like you say, with Fortran. And I mean, I started with I did a little bit of Fortran. Well, I did a lot. My first programming job, I did a lot of Prolog, which is a really weird language.
Yeah, it's going back a bit, isn't it?
Yeah, absolutely. Yeah, on VAX 11750s. But Python, I love Python. I think it's just a masterpiece of program design.
Yeah.
Anyway, is everybody back with us?
Awesome.
Right. So I was looking in the comments actually, and I noticed that somebody made a comment about the documentation is incredible, and that must have been a bigger effort than the actual compiler. Well, it's a dirty secret, and I think I showed you it when we were on the last week's, but you might not have noticed it. If you, like, for instance, this is our little program we did for our motor control. This is a function. So functions, classes, or all these types of things are code modules, if you like, whereby this is a little module which is designed to send a command to our motor. Now,
do you see what you're sharing there?
Oh, right, sorry. There we go. Yeah. This is a small module which we just wrote to control our motor. Now, any module if you go to the first line of a module and you do a comment which is the triple quote comment, which is actually called a doc string. That's what they're called, and you'll see the reason why in a moment. If I do controls the motor, so I'm just doing an ordinary comment in here. If I spell it right, can't type and talk at the same time. I'm hopeless. Controls the motor. I can put, because it's let me just finish off the doc string. The nice thing about doc strings is they're multi-line as well. So I can go on to the next line and I can say something like forward equals forward, and I can say rev equals reverse. So I'm basically putting a comment in which explains how it works, and speed is equal to 0 to 65,535. There you go. So I've documented my function, which is good practice. Now, this is the dirty secret of all the stuff that all this clever stuff that everyone's saying, oh, it's really clever how it's all documented. If I now do motor, hey, look what's happening. Look, controls the motor, forward equals forward, reverse equals reverse. No. So these comments that I've just typed in instantly become part of your documentation. That's one of the fantastic things about Python. And in my day job, whenever we write a function for work, we have a set layout, and we comment like this, and then we run a documentation program called Sphinx. And for those of you that are interested in documentation, you'll like that. You run this thing called Sphinx, and it basically takes a cascading style sheet and applies it to all of these doc strings, and then instantly you have a complete manual for all of your software, which tells you exactly how to use it. So it's super, super clever the way that all that works. So all this stuff here just comes from these doc strings. And so if you're organized, which I'm not, you type these in. In fact, good programming practice would say that you should type this before you actually type the code, so you know exactly what you're going to do. It's like a plan, and then you write the code, and all being well, the two match, and then all your documentation just flows through from there. So anyway, I thought I'd just show you that. So back to what we were doing. So the GUI that we're going to end up with is going to look like this. This is what I intend to use to control my motor. So I'm going to have rotate left, rotate right, stop, and a way of setting my speed on a it's actually working. A way of setting the speed and an exit button. So that's basically what we're going to create. And as Tony just asked the question, how do you put more than one widget on a row? Well, you're going to see how to do that in a moment. It's very, very simple. So what we're going to do now is create a new file. So actually I can duplicate that one. Just in fact, I'm going to get that one. Let's just go over it. So we need a new file. So file new. Don't know what I did. Oh, that inaccurate mouse control. New file, and we'll call this one RA. Everything starts with RA, and we'll say GUI control. So let's just go and save that first. Save as, and we're going to call it RA GUI. Lazy finger. Okay, so the first thing we're going to do is import Simple Gui. So Simple Gui, there it is. So we'll import that as SG. If you remember, we said that that's the sort of the accepted standard. We're going to, are we going to use that? And because we're going to be controlling our Raspberry Pi Pico from this PC, this is just a Windows PC, we're going to use the serial connection, which is in fact a USB connection. So I'm going to say import serial, which is the class that we need to talk RS-232 or USB serial over USB. It's a class called serial, which is we'll look at in a moment. So the first thing we need to look at is our layout. This is our pencil drawing thing, and as you know, layout is a list, and inside that list it has a number of other lists for each row. I'm just going to move that up to there so that it sort of makes a bit more sense. So my first row is going to be a list, and I'm actually going to have 3 rows. So I'm going to do the first row there, and then second row we'll do there, and the third row we'll do there, like that. Okay, so that's our 3 rows. Have we got 3 rows? No, I've actually got 4 rows. 4 rows, so I need 1 more row. So that's our 4 rows. Now each row has a number of widgets on it. The first one we're going to do is going to be a text string that says motor control. So I'm going to do SG dot, and here's all the widgets that you've got, and the one I'm going to use is the text object. So if you look down here, you'll see that it's actually uppercase T, so it will come up, is text. It's that one there. So display some text in the window. Usually this means a single line of text. There you go. And for those of you that are interested in these doc strings, by the way, if you actually go and have a look at that class, you can, in Visual Studio, you can right-hand mouse click on this, and I think it says go to source somewhere in here, and it'll bring that that source code up. You can have a look at those doc strings and see how they're done if you want to learn more. So I'm going to I'm just going to say motor control there. I'm going to, then that's my first widget. I'm going to have another widget now, which is going to be some more text, and this is going to be not going to say anything, and it's going to have a key equal to output. What key is means that when you press the button, if you remember when we looked at the simple example, when you press the button, you get these values back. Well, the key is one of those values, so you can tell it what you want the object to be known as. So that's, or if you want to call that object, you can give it a key in that way. So that's our first row. This will become a more apparent once I run it. So the second row, I'm going to have a button, so I can do SG dot button like that. Now I'm actually going to call this a real-time button. There's different types of button. Just to confuse you, the one I'm going to use is called a real-time button. And there's a reason for that, which I'll explain in a moment. If you do an ordinary button is like an ordinary Windows button. And if any of you that are sort of paying attention will realize that most button widgets in Windows will only activate when you let go of them. I don't know if you've noticed that behavior. So when you click on them, nothing happens. When you let go of them, it's when it happens. And in fact, it's very useful as a user, because what it allows you to do is click on a button and then go, oh, I didn't mean to do that. And you can move away from the focus of the button and let go, and it doesn't activate that function. And the widgets, these widgets work the same way. Now, if you are controlling a motor like we are, you want to be able to have instantaneous action, which means that you don't want the motor to move after you've pressed the button. And more importantly, when you press the stop button, you definitely don't want it to wait until you let go of the button. You want it to stop instantly when you press it. So in order to do that, we have to use what's called a real-time button. And a real-time button allows the action to happen at the point where you press it. That's what a real-time button is. So hopefully that's cleared something up there. Now, the button, the text that's on the button, I'm going to have a left-hand arrow, which is just a smaller than sign. So if you remember, I had my left button, my stop button, and my right button. So that's my left button. Now, there are lots of different attributes that you can assign to these now, and you can see them all in here. So one of those in there is size. So I'm going to say what size the button is that I want, and the size of this button is going to be equal to, let me think, 10 by 5, I think is the size that we want. So that's my first button. And then my second widget is going to move my stop button. So here I want to do SG, and it's another real-time button. With a dot. Come on, type properly. Real-time button. There we go. I was waiting for it to come up, so I didn't have to type it all. This one is stop, and size, do the same. Size is equal to, just 1 minute. The size again is, where are we? Size is equal to 10 by 5. Okay. And then the third one was the right button. So in fact, we can just copy that. It's exactly the same. Copy that and paste that in there. Makes life a bit easier. We've just got to change the arrow. Oops. Oops, no, we do need that on the end. Why is that wiggly? What's it saying? What have I done wrong? Got too many brackets or something? I think I have. Is that not right? It looks right to me. Why am I still getting wiggly lines?
2 brackets after the first size.
2 brackets after the, oh, this one here.
Yeah.
Oh yeah, thank you. The stop one, that's the stop one there that needs it, isn't it? There you go, that's it.
Oh.
Yeah, that's right now. Yeah, because there's 1 bracket here. In fact, the way to do it is you can count up for every open bracket. So 1, 2, and then and subtract for every closed bracket. So if you start there, you go 1, 2, 1, 0. You should end at 0, and then that's if you want to. Sometimes you need to go through that process just to make sure that you've got the right number of brackets. The nice thing about Visual Studio is that it does do that wiggly red thing, so you do know there's something wrong. So that's our first row. So the second 2 rows, what I'm actually probably going to do here is just sorry, I'm talking to myself again. What I'll probably do is just paste these in for expediency. So if I just paste this in here. So that's my my second my last 2 rows. So the next row down, we've got a slider, which you saw in action, which is called slider. It's horizontally orientated. This means that when I move the slider, things will happen. That's what enable events means. The disable number display false, which means it will display the value. So you can turn that on and off as well. And lastly, I've got this button, which it's not lastly, but there's a button that says set speed on the end of it. And lastly is my exit button, which is just a standard button, which is called exit. If you want to do it, you could do that just to show that where the rows are. So that's all my rows. Now, you know, go ahead and play around with this library. The documentation, as I say, is marvelous. So, and there's loads and loads and loads and loads of examples, and you can do some really cool stuff with it. You know, you can do, you can put matplotlib objects in here, so you can have graphs, and you can have buttons to that manipulate graphics, and all the things we've been talking about. You can put into your GUIs using Simple Gui, and none of it's much more complicated really than this. So all we need now is to wrap a window around it. So let's go back to the left hand side here and say window, and the window is going to contain right, we've got to tell you that it's a window. So sg.window is what we want. It's capital W. It is window. So this is how we specify the actual window, and all we have to do is the bare minimum is a label for the window, and this one's going to be called remote motor control. And then our layout, which we've called conveniently layout. It doesn't have to be called layout, but we called it layout. So all your layout needs to be, as it says there, is well, is a list. It's a list of lists. That's all it is. Now that's all we need to basically invoke the window on the screen. So theoretically, if we run that now, we should get our window. We won't get any events or anything from it, but let's give it a go. So if we do that, no window. Why no window? Oh, actually, I know you have to have the events bit. Oh, sorry, I lied when I just said that should work. Now it doesn't. You've got to actually read the window. So that's the bit we're going to go on to do now. So we're going to have a like we were saying, is to analyze the events. We need a while true, which is our standard way of having an infinite loop in Python. We're going to do exactly the same as we did in the example. We're going to say event and value values, and those are going to be equal to window, call it window dot, and we're going to read from the window. It's the method. So that there is going to get us on the road. Quite why it's got a blue wiggly line, I'm not sure it's saying. The biggest deal method of the window class this now. I don't know why it's underscored in blue, but anyway, I'm sure it'll work. So let's just start by doing print event and values. That way we can see what is being printed out. Oh, is what's coming in. So here's the code. If event equals sg dot win closed, or equal to exit. Do we call it exit? We did, didn't we? Yeah. Sorry. Now, what that line of code there does is we're in an infinite loop. If somebody on the GUI presses the exit button, remember we created a button here called exit, well, that's going to come back into this value called event. So all these events that happen in here are going to end up in these two values here. And as this goes round and round and round, if we were to press that button, the event would have the word exit in it. If that's the case, then we're going to do a break. And what break does is it gets us out of this loop, which means that the program then stops. The sg.winClosed is the X in the top corner, this thing here, this red button at the corner. That's represented in Simple Gui as win closed. That's what that means. So if somebody clicks that button, then also close the window. So you're in control of that as well. That's why we have this if statement, which is either that or that. We'll close the window. That's what that means. And then we've got to fill in what we want to happen for all of the control buttons. But before we do that, I'm just going to put another line of code on the end here, which is going to be left justified, which means this will happen. I'm going to say window dot close at that point there, which is the method. The reason for that is that when this is going round and round and round, if you press the exit, it will dump out of here, but the window will still remain on the screen. So we have to say window close in order to get that window to close. That's basically what that means. So now we've got the window read in there. Theoretically, this should work. Let's press there we go. So there's our GUI. Now none of these buttons are going to do anything other than print out. So you can see here, if I press left button, it's get left button, If you press this one, you get that one, you get that one, you get that one, and if you do the slider, you get those values. If you do set speed, you get set speed, and if you do exit all this, it will disappear. So that makes it disappear. Let's get it back again. Let's just check it and exit. That makes it disappear as well. So this all works. So it's pretty quick and easy to get a GUI that looks like that. If you were to do that in Qt or one of those others, well, if you were to do this in Windows in C++, it would probably be about 3 hours of programming just to get that on the screen. I'm maybe exaggerating slightly, but it certainly would be a lot more painful than that. And once you get familiar with this, you can knock these out in pretty quick order. It's a pretty smart environment in that regard. So yeah, let me just show you. Set speed is an ordinary button. So look at this button here. When I press it, it produces a value straight away. When I press this button, nothing happens until I let go. Hang on, there you go. If I press it and move away, let go, nothing happens. So that's default Windows behavior. That's what a button is. A real-time button is this. Press play. I didn't activate the release, but you can interrogate the release. It just was going to make it a bit too long-winded and complicated, so I kept it simple like that. That's why we've got start and stop separately. I mean, ideally, you probably have it so when you press it, it starts, and when you let go, it stops. But it was just it was going down a rabbit hole on that one. So, so this is our basic GUI function. We now can tell when each button is being pressed. So all we need to do now is establish communication with our Pico to control the motor. So how are we going to do that? Right, well, that's pretty easy. We're going to use this serial class. So in order to communicate with the Pico, we're connecting to the Pico. If I go into device manager, you'll see that COM ports here on COM6, I've got this Silicon Labs UART bridge on COM6. It's one of those little USB dongles that comes out as TTL, if you remember from the diagram. So that's connected to my Pico on COM6. So all we need is a line of code in here, and I'm going to call it Pi, because it's my Pi that I'm going to be talking to, and it's serial. Oops, serial. We'll get there spelling wise today, I'm sure. Serial.serial. I know it sounds a bit weird having serial and serial, although it is uppercase S. Serial.serial, just to catch you out, and it's COM6. That's easy. And all we then need is, these are the two minimum things you need, and a baud rate. So we're going to be talking at 9600 baud. So just put 9600 in there. This chip will work up to some crazy speed, you know, I don't know, half a megabit or something. But 9600 is absolutely fine for these messages. They're only little simple messages. So that will open the port, connect to it, and everything will be hunky-dory and we'll be all ready to write to it. So all we then need to do is write some, come up with a protocol and send those messages to the other end. So let's dive in and do that. So what we want is whenever we press those buttons to send a command. So in here, if it's not closing the system, then it's going to be one of those other buttons. So we can do an elif, we can say event is, and here we can say whichever button we're looking for. So our right hand button is the less than sign. Oops, is the less than sign. So that allows us to detect our left button. Think about how we're going to do that. Yeah, that will do. So for the left button, all we need to do is send a command to our Pi to make it go left. So to do that, we do pi.write. That means write out of the serial port, and then I need to tell it what I'm going to write. So we might as well just use a similar protocol as this. I mean, keep it simple. So what we'll do is we'll send the same symbol, but I'm also going to make it life a little bit easier, because when you're sending commands, the best way to send a serial command, or one of the ways, is to make sure that you have a recognizable character at the end of the message, so you know when the message is complete. And a very typical way of doing that, especially for what are known as terminal protocols, is that you end in a carriage return and line feed, because that denotes that there's a whole line of information being sent. If you imagine typing in a terminal, you type a word, you might type a particular command, and then you hit the carriage return, and that sends a carriage return line feed on the end of the signal, and then it executes the command. So we're going to do something exactly the same. This is what will, as I say, what is known as a terminal protocol. And to do a line feed or a carriage return and line feed in Python, we can use slash characters in here, so escape characters. So that's an escape character. So escape R is carriage return, and escape N is new line. So that's the carriage return line feed. It's the same protocol as in C and lots of other languages. You can put the hexadecimal values in there as well if you like, so you can put x0, actually it's x10, isn't it? So that's the hexadecimal value. You can put the denary value as well if you like. There's all sorts of different ways. But for carriage return and line feed, typically you would use the escape R and escape N. Now in Python, this is something you need to remember if you've come from C or other languages. Python is 100% Unicode compliant. Now what does that mean? Well, Unicode allows you to do Chinese, Arabic, all different languages. It's not just Arabic characters or letters like these. So the problem with that is that each of these characters, so for instance, in this case, this character here, potentially, well, let me type an ordinary character, say the letter R. Now the letter R looks like one character, but in Unicode, potentially that could be up to 3 bytes of information to allow you to have all these different alphabets. So in order to make sure that we are just sending out ASCII information here, so each character is just 1 byte, we can put a B in front of the string. And if we put a B in front of the string, it just means that this now becomes what's called a byte array. And a byte array is literally each character only takes up 1 byte. So it stops this Unicode problem. So get into the habit. This would work fine, to be honest. And I put this in because I deal a lot with Unicode stuff, because we have customers in Russia and in the Middle East. So if you put the B in front, when you want it to be just straightforward, a straightforward array of bytes, put a B in front of it, and then the interpreter will make sure that it doesn't represent them as multiple bytes. So if you're ever sending strings down a 232 line, and at the other end you go, hang on a minute, I'm only sending like 2 characters and I'm getting 6 at the other end. What's going on? It's probably to do with that. So I'm going to write out the left-hand arrow. So all I need to do now is at the other end write some code to receive that right-hand arrow, left-hand arrow, and move the motor. We'll do that in a minute. Let's go ahead and complete this this series of elifs. And in fact, what I'm going to do is I'll just copy those from my notes, and then we can just speed the show up a bit, because otherwise we're going to be running over again and we're going to a third class. Right, so there's my left arrow, there's my right arrow. Hang on a minute, that's not quite right, is it? That's just been tabbed in slightly. Switch your tabs. You can see how the red wiggles catch me there. You see how it's saying that it's indented. So get that right. I know some of you that have come from other languages are struggling with the indenting, but believe me, with a little bit of practice, it becomes almost second nature. You just have to discipline yourself to remember that groups of code need these tabs. So there's my left-hand button. There's my right-hand button. I've done exactly the same protocol for that. Here's my stop button. Hey presto, we're using the word stop. And then the last one is my set speed. This is a little bit more complicated. So what I've got is I've got the word speed, but then I've got a comma, and then I've got the value. Now the value is the value of the slider. I have used the format command. So it's an absolute value because you can have negative values. So I've made sure that it's an absolute value. And I've also used the encode method on it as well, which means that it renders it as a byte array value. So when you're getting into these number types, you have to start thinking about encoding and decoding and all these other things. It's probably unnecessary that, but the fact is that this actually does work. So and this means it's a floating point number coming from the left, but I don't want to see any decimal places. So that means no decimal values after the decimal point. Now again, this formatting here, I don't expect you to, this is something that you pick up over time, but as you start using format more, you'll see that there's all sorts of notation that you can put into these values to help, bless you, Norman, to help you resolve number formats into the right way. But you'll see this one does actually work. So now we've pretty much got our program complete here in the respect that, in fact, let's go ahead and run it. Yeah, nothing will happen at the other end. So if I'm just going to save this first, and then if we go up to the play button and we run it, let's just make sure everything works. So let's press the left-hand button. That worked. Right-hand, the stop button works. Right-hand button works. That works. Set speed works. And now it worked in the respect that we didn't get any exceptions. So it means that the port did open. And it also means that it was able to send these strings out of the port. It's just that nothing was getting through. We haven't put any error checking in here. If you were doing this for real, you'd probably have something that acknowledged from the other end, so you could then make sure that you knew that you were properly connected and that the other end was receiving your signals. And obviously this is that's slightly beyond day one class. But the fact is that this now is all ready to control our motor. So let's go back to any questions or anybody got anything that they want to ask about this so far?
Can I ask one, Rupert?
Yeah, Andrew, go ahead.
When you were defining the layout of the buttons, when you did the motor control button, you keyed it as output with a dash at either end. Is there a significance to the dashes?
No, this is just a string. I think this is just like a label. So did I use key anywhere else? I think I was going to use.
Yes, you used key in slider as well.
Oh, I did. Yes, and as you can see that it's actually called value slider. I think I was going to do something with that. I was going to put some feedback or something on there originally, so that's why I gave it this name.
Okay.
But those are not relevant. No, I don't know why I did that. Just a weird thing. I don't know.
Okay, no worries. Because I'd seen things with dashes and double dashes that are still mystifying me, and I thought, oh, there's something clever there.
It's quite. What is nice is that if you don't put the key in, it uses the text that's in the button as the key, but you can override it by saying what the key is. So because the slider hasn't actually got, I didn't do any text on the slider. That's why I used the word key. Because if you look at when we run it, I don't think there's many text next to the slider. No, with that's the. I think you can put text and it appears in here, but you can have different text and a different key for each object as well. So no, there's no relevance to that. So let's go over to our motor then, our Pico, I should say, which is RA motor control GUI. No, that's none of those, is it? That's the one we're in. So we need to go and get our Pico, which is RA motor control, is that one there. So this is our motor. So let's have a look at adding the bits that we need there. So yeah. So first of all, at the moment, did we import UART? We did. You can see that we're not using UART because you can see how it's slightly paler green color. That's Visual Studio saying, oh, you've imported this, but you haven't used it. Let's go ahead and implement the UART control. So in the same way as on our PC, we also then need to use, we need to set up this RS-232 or serial USB serial connection on the Pico. Now the Pico has got, I think, 4 UARTs, I think. We're going to use UART 0, which, so in, where am I going to do it? I'll do it under my button. That seems like a logical place to do it. So I'm going to call this, I'll call it UART 0 just for the hell of it. So UART 0 equals UART, which is the class itself, implements the standard duplex serial communication protocol, as it says there. The UART I'm going to use is 0. That's my first parameter. The baud rate is going to be, if you can remember, 9600. My TX pin, I am actually going to have a TX pin, even though I'm not going to use it. I'm going to say TX equals pin 0. So that's my TX pin. Of course, I'm going to have an RX pin, and that is going to get used. So RX equals pin 1. And last but not least, I'm going to put timeout equals 0. No, I'm not going to timeout equals 1. And what that means is that if you start receiving characters and you haven't received the end of the characters within a second, give up. So it's a way of just making sure that if you get junk coming into the UART, that it's not going to stick around and block the system. So it's just an option, and allows for it to time out. So what we also now need is in our infinite loop. If we go down to our infinite loop, which at the moment is just looking at our button being pressed, what we also need in here in our infinite loop is a way of reading the UART. So I'm just going to put it, where am I going to put it? I am going to put it immediately after the, do we need the sleep in there? Let me think, should we leave the sleep? We can do, it doesn't really matter where it goes. Let me put it in before the sleep, because I like to have the sleep at the end so that you can see it. So at this point here, so this is inside the loop, but nothing to do with this. This is just sensing our button. So we're going to, at this point here, I'm going to create a local variable, which is going to be called command. And at this point, I'm just going to say equals none. I'll tell you why I'm doing that. But what I'm doing there is I'm creating a namespace, which I'm going to use to store my command, which is coming from the other end. And at the moment, I don't have a value to put in it, so I'm just saying it's equal to none. It just makes an empty namespace. And then I'm going to say cmnd, cmnd equals, and UART 0 is our UART object, and all I need to do is do dot read line. So you can see there you've got read, read into, and read line. Read line is the one that we're going to use, and the reason why I use the carriage return line feed in our terminal protocol is because read line sorts all that out for you, because the line ends in a carriage return and line feed. So it makes a lot of sense to use that method of communication. It's simple, it's easy to read. You can operate it then from a terminal, and everything works out well. So that is going to basically wait for a second, or sorry, if anything comes into the port, that will then read that information. Once it starts reading it, it will keep reading until it either gets a carriage return line feed or it times out. That's basically how that is going to work. Obviously, that's all a bit magic. You don't see or know any of that, but that's basically what's going to happen. Just to let you know, for those of you that are worried about how it works. So, if command, my first command is just if command. Now, what that means is that don't bother doing any of this following code unless something's come in, because we're going round and round this loop at the moment. And we can still detect people pressing the button. So potentially someone could be using the buttons and they could be controlling it remotely. So that means only do the following piece of code if there is something in there. But it's a shorthand really for if it equals that you could put that as well if it makes more sense to you. Meaning if it's empty or if there's nothing in it, then don't bother. But the shorthand for that is just that, because the way that if statements work is that anything is true and nothing and nothing or something that's empty is false. So that's basically it. So so what we're going to do in there, I'm just going to do the first one and then I'll copy the rest in. So the first thing I'm going to do is I'm going to convert the byte array. You remember we put that B in front of the string. That created what's called a byte array. Now the problem with byte arrays is that they aren't as well supported in regards to the manipulation. The manipulation of words, if you want to use a sort of a loose term, in Python is fantastic. It's one of its best points. But they have to be strings, so they have to be in an actual string format rather than being a byte array. Byte arrays are the realm of things that go down wires. So in order to get them back into strings and to make our life easier, we have to decode them, and it's very simple to do. And I'm actually going to create another command, which I'm going to call S command, which stands for string command. And I'm going to say equals to command dot decode. So all strings, all byte arrays have an attribute available to them. This is the object oriented thing. This command here, which has been coming back from our serial port, is a byte array. All byte arrays have this decode function, which turns them back into a string. That's why I used the S to tell myself that, that this is now a string. So once we've got it in a string, we can then use a lot more powerful tools to make it to detect our characters. So to detect our first character, if I say if that is in S command, so that means that if you find this character anywhere in this string, that's what the in is. See, in is a really powerful command. It'll look through a whole chunk of text for a particular command. So it works very well for us here. It means that we've received a move the motor left command. And that's exactly what I'm going to do. I'm going to say motor. And we need it to, this is the reverse function, so I'm going to do reverse, and the speed is going to be the set speed. Remember, we created a variable at the top, set speed, and it's 0.65. I think it's set to 30,000 at the moment. The reason for using this variable is because we now have we've now got the ability to set the speed from our GUI. So it means that we can change this value using the return value from the PC, which we're going to do in a moment. So let me just go ahead now and bring in all the other commands so that you don't have to sit painfully watching me mistype everything. That should do it there. So if we come down here, and I think, actually, I think it, so there's my left-hand button, there's my right-hand button. So it's exactly the same, but we're just looking for the right-hand arrow. And this time we're going to send the motor forward by a set speed. And this one is going to stop the motor, and which is the 0, if you remember. And then if we get the word speed, we're going to use the split command. And what the split command does is that it says if you find a comma, the value either side, split those down into 2. So what we'll end up there with is a list. Speed val will be a list, and it will have, in this case, it'll have 2 values in it. One is the second value, which is 1, of course, because it's indexed from 0. The second value is the actual speed. So we're going to say set the speed to the integer value of that. The reason why I'm using the converter there is because if we go back up here, you'll see that set speed is set as an integer. This is not a string or anything, it's an integer value. So that's what my int is on there. So that changes our speed. I think all we've got on the end of there then is our wait 0, 1, isn't it? Let's have a look. Yeah, so we've got our time sleep there, which allows this thing not to flog itself to death unnecessarily. There's one little thing I'm going to change here. Is that this here, I'm just going to comment this out. Don't worry why I'm doing that. Well, I'll tell you why I'm doing that. This if else business, it means that this will constantly stop the motor, which means our GUI doesn't work. We can make that work in a minute, but at some stage. But at the moment, just forgive me for that. But we can press the button and make the motor spin, but it won't stop when we let go of the button. But we can now control it from our GUI, which is more important. So we haven't yet tried this. So this, of course, runs inside the Pico. Now our Pico terminal isn't showing there. So if I go down to here, I can go to Pico console. There it is. And at the moment, it's running the original code. Let's run the new code. Let's hope it runs without exceptions. That would be a good start, wouldn't it? Syntax error. Invalid syntax line 42. That's because I can see why now. You see how I've got if and else, and then I've commented out the command. This command there's no command in there. So what we have to do is put the word pass in there. You're allowed to have pass is counted as a command that does nothing, but it allows the syntax of the interpreter to be happy. So that's all that hopefully is. So let's hit run again. And hopefully, no, we've got some more errors. Line 10 in module, extra keyword arguments given. So line 10, where's line 10? UART, extra keywords given. What is wrong with that?
Is timeout spelt wrong?
Yes, it is. You're quite right.
And the missing E.
It's missing an E. That's better. That was a well spotted, chaps. I'm a dreadful speller. There we go. So that's the advantage of putting that line of code in that prints out something at the beginning, because it always makes you realize that generally the interpreter is working and it's all okay. So let me just let me bring up the motor again, so you can see everything on here. Now, as I said before, if I press the motor, I won't do it, but it'll just start spinning, and we won't be able to stop it. What we need now is our GUI. So let me go back to our GUI, which is here. If I press the play button on here now, we should get our GUI come up, which we have. So there's our GUI. There's our. We can see everything at this point. So let's go for a spin. There we go. So there's our motor moving around. Let me press stop. That stops it. Go to the left. It stops it. Let's make it go a bit faster. So I think we were at half speed. So let's go full speed. What the hell? So I'll move that to 65,000, do set speed, and then there we go. It's a bit fast for an antenna rotator. Might be all right for radar, that one. Let's go slow as we can. I don't know what this gearbox is in here, but oh, no, I didn't do the set, did I? You got to do set. I haven't written it very well. There you go. That's its slowest. Even that's a bit fast for a rotator, I think, but you get the idea. Other gearboxes are available. So that's left, that's right, and that's stop. Fun, eh? You can. There's never any. It never gets tiring controlling motors from computers. So there you go. There's our Gemini control center. That's all that they've got. I assure you. It's. I'm sure that behind all that, there's just a Raspberry Pi Pico controlling an 800-ton telescope. Any questions before we move on?
Yes, I've got one. In your list of, in your controller, set speed is the last LF. It doesn't seem to mind that. In C or something like that, you've got to define it before you've defined the other ones.
Whereabouts, sorry?
At the bottom, you've got, no, that's not the right one. Yeah, in the
on the Raspberry Pi, you mean?
On the, no, I think it was the other one.
This is the control one. This is the Windows.
Oh yeah, it goes to the Raspberry Pi one.
Right, the Raspberry Pi one is motor control, that one. Yeah.
And right at the end, your if command right at the bottom is set speed, and yet you use it 4 or 5 lines above. And is that allowed in Python? Obviously it is. You wouldn't be able to do that in C, for instance.
Set speed was defined up here. It's a global.
Right. Okay. Yep.
You can do that though. You can do that in Python, but what it would do at that point is it would create a local variable.
Right.
That's something that comes as a bit of a shock to most people in C. Is that if I want to, I could say I could have a I can have a variable like that in there. That'll run fine. It won't cause an exception. Because what the interpreter does is it says, well, I've looked on the outside of this scope and I can't see anything called Rupert, so I'll just create a local variable called Rupert. And at the moment, that is global scope, in fact. But if we were in a function, say we're in motor, then it would just create a local variable, which would only ever exist in this scope here.
Yeah.
So it's a bit confusing because you can define variables without any statement, or you don't have to say, here's a new variable. It just, now that can catch you out, because if you do something inadvertently, like do set speed, if I did that, thinking that I'd got the same variable, well, that's probably a little bit obvious, but you might do something like, just inadvertently, you do something like that, and you think it looks like set speed, and you can stare at that for a very long time and think, why is it not working? And what's happened there is that the interpreter says, oh, there's a new variable here called set speed, spelt with an A. That's not the same as this one, so we'll create a new one. So we have a new variable now called set speed. Now that occasionally happens when you do a typo, and you can stare for a long time at a problem like that. Whereas that's the advantage of a compile environment. The compile environment would say, this is a different spelling. You've spelt it wrong. But interpreted, well, Python specifically is really cool the way that you can create variables on the fly, but it can shoot you in the foot at the same time. Any other questions?
When you do the read line from the UART, does that always come back as a byte array? So you always need to do a decode?
Yes.
Or
yes.
Yeah,
it does. Yeah. It will always come back as a byte array, and you can't use this in command with byte arrays. It doesn't exist. It's a string command. Byte, you can still manipulate byte arrays, but it's much more C-like. Then you get into having to chop it up into chunks and do comparisons, and whereas Python's got some marvelous string comparison stuff, which makes life much easier. And of course, you can use regular expressions as well. You can use regular expressions on byte arrays, but they're easier and more efficient on strings. And regular expressions, if you're doing complicated protocols, then regular expressions are definitely the way to go, but definitely outside of the scope of this class.
Is that the same if you read a UART on a normal Pi?
Yeah. It's a Python function. The way to remember it is anything that goes down a wire. So if it comes, on RS-232, or it comes on a USB port, or it comes down an Ethernet cable, the chances are it's going to be a byte array.
Okay.
If you're ever in doubt, just do .type. If you want to see, like, for instance, this value that comes back, what we called it, command, haven't we? If you do just do type. We did this, I think, last time, didn't we? And we do CMND like that. If you do, oops, we'll do a printer. We'll do like that. If you do that, we're going to get that we're going to get it every.
Yeah, no, that's okay. Don't worry. I understand.
Yeah, exactly. Yeah, you understand. So if you're ever in doubt what shape or size something is, there you go. Oh, of course, at that time, it's a non-type. It's just not, we haven't sent anything. Hang on a minute. That's an interesting one in itself, because you can see there that it's two different types. Of course, it's a non-type until I do this, and then it becomes a. Hey, let me stop it. Stop. And then it becomes a byte. Bytes, as it's called there. So that's a byte array. If I were to put that same line of code underneath, let's copy that to there. I'll tell you what, let's move that to, if we move that to here. We move that to there. That's not going to be quite so crazy, isn't it? Oops, run. There we go. Where are we? Where's my Gui gone? Right. There you go. Oh, it's all bytes. Oh, it doesn't say string. Ooh. I'm a bit bewildered by that. Why is that happening?
Because the S command will be the string there.
Oh, thank you. Thank you very much. Here we go. This time it's going to be dynamite, as they say. There you go. That illustrates exactly what we're talking about. So yeah, don't forget to, when you're learning, this type command is actually really handy, because you can get very confused about types and what you can and can't do with them, and that makes life done slightly easier when you can just ask it what they are. Good. I'm going to move. Yes, go on.
Can I ask you a question about the overall design of the hardware? I know you used a separate UART board, but presumably you could have been feeding the commands into the USB port on the Pico, can you?
Yeah, the reason why I didn't do that is because I wanted to be able to see the wood for the tree, so we can see the debugging separately from the UART, from the control. It just sort of was a bit cleaner for this class. Interestingly, though, I've started doing debugging on the UART since I set this up for this class last time. I suddenly realized that when you're doing debugging, it's actually quite nice to have it on a separate channel like that, rather than on your programming port. It somehow has I can't think off the top of my head the reason why I've been doing it like that, but it has been working quite well. So having a sort of one of these TTL dongle things plugged into your UART does have its uses. But I just did it just to introduce some of the other elements and the whys and wherefores of doing it. But you're quite right, Tony. You could use it.
I mean, if you were just trying to get the ultimate cheap control,
Yes,
You
yes.
could have actually put a Pico with a couple of FETs on the output driving the motor directly, and
Yeah,
it would
absolutely.
cost you $3.
Yeah, it would. I mean, the chip that's in here, I mean, this board was only £1.79 delivered or something from our friends in the Big Rock Candy Mountain.
My only worry about encouraging China to send all those boards this way is that they're undercutting all of our industry, whereas Raspberry Pi producing the Pico is actually doing it. I know it may be made in China, but it's all controlled from here.
Well, we're not. Yeah, the ethics of that you can resolve yourself. I'm just showing you how Python works. So
yeah, absolutely. I'm not criticising. I just
no.
I just
it's
think
very
we should
tempting.
always try and use our locally produced stuff.
Actually,
if we can.
I'm actually telling
Do
a
we
lie.
have any locally produced stuff?
Actually,
because
no.
I've never been able to find any.
Do you know what? Do you know what? This board is actually a British board. I've just realised. I've lied to you. It's made by a company called rkeducation.co.uk, and it is actually made in the UK.
Oh, brilliant!
Yeah, and it is only cheap. It is only, I think it's about £2 something. I mean, it's only got one chip on it. It's only got I can't remember what the chip is, but it's a dual H bridge. Actually they've got some quite nice boards. rkeducation.co.uk. It's an L293D is the chip.
Well done.
I think it works up to an amp or something. It's fine for little motors like that, you know.
Thank you, Rupert. I stand corrected.
Can I just ask one other quick question?
Yes, Callum.
On powering it, the Pico. So if you were to power it from a separate power supply onto its pin 40 or whatever the number is, if you plug it in on the USB as well, is there a conflict of the two power supplies?
This is entirely powered from the USB. The motor's been operated by the USB.
But if you wanted to do that as a standalone thing.
Yeah, well, when I actually originally did it, in fact, I don't think you can still see the wires, but I had the power coming from a power supply to power this. So I was running this on 12 volts and it was whipping around really quick and it was a bit too complicated for this. But I had 12 volts going into this board, and then I had the Raspberry Pi just being powered from the USB. But obviously, you just got to make sure that you don't connect the two together. That's fine. This board is obviously designed for having separate power, rather than, you know, I've actually just taken it from the what is it called, V bus? I can't remember what the second pin.
Yeah. No, I was just thinking on a generalized solution to a problem like that, where
there's no way on the Pico board, is there?
When it wouldn't normally be plugged into the USB and you're running it standalone.
No, if you're running it standalone, then you'd have a power going into that first pin there.
Yeah, but then if you were to doing some debugging or something and wanted to upload a new version,
I don't know whether there's a diode or anything in there. I'm not sure. And there's no jump. Some of these boards do have the capacity to enable and disable the link there, so that to stop that from happening.
I've noticed that on some of the like the 3D printer controller boards have.
Mine hasn't got that. That's annoying. My 3D printer, if I switch it off and it's still plugged into my Raspberry Pi, it tries to power the whole 3D printer through the USB port, which is really annoying. I keep meaning to put a relay in, but I haven't got around to it. But I haven't had a problem with that so far, linking the two together. But I don't know whether I've actually had that. Anyway, right, onwards and upwards. We've got basically half an hour left. There are two things I was going to show you. One is using a Raspberry Pi 3 and a GPS to get accurate time into Python. We're not going to be able to do both of these, I don't think, but we can have a good go. Then the second one was probably of more interest to you, was RTL dongles. Yes. How to get data from an RTL dongle into your, and draw fancy charts and all the rest of it. Do you want to do that? Should we start with the RTL dongle and end on a GPS? Does anybody?
Yeah, RTL first.
Yes.
RTL first, right. That's what we'll do. Right, RTL dongle first means what I'm going to do is, let me go back to my screen. I'll go back to me. No, it doesn't matter. I was going to try and show you. Well, I don't need to describe this. Let's just go to the screen. We've finished with that now. My RTL dongle is in the room with us here, so I haven't got an antenna connected to it or anything. So it's got no, I mean, other than probably local radio stations and things. There's nothing much on it. But it doesn't really matter. It's the data and the code that we're here to see. I've actually got it in a Linux machine, which is on the other side of the room. So I ended up with too much going into this machine. So what I'm going to do is I'm just going to use no machine. I don't know whether any of you, I found this this program a while ago, but it's I've been using VNC, the screen scrape stuff for a long time, but no machine is a bit of a new kid on the block, but it works ever so well with Linux and Raspberry Pi, is much better than VNC, I find. And it's free. And it is a screen scrape type technology, but that's what I'm going to use. So I've got my laptop over here. So let's just log on to that. So click that. The nice thing is that compared to VNC is that it logs you on as the screen user. So I can go to the laptop and this it's basically working in tandem, which on Ubuntu you can't do with VNC. It logs you on as another user, and what that means is that then all of the libraries, when you're working in Python, we had this conversation, Paul and I, earlier about virtual environments. If you install all of your libraries, quite often they're associated with a user and a particular machine, and if you then log on remotely, you don't get access to those because you're a different user. Whereas with this no machine product, you come on as the screen user, so all of that, or everything works, which is the point I'm trying to make. So we're going to look at a Jupyter notebook here. So this is Ubuntu. Run with Python 3.8, I think, is running on it. And so what we're going to talk about is how you get data in and out of, I should say, RTL dongles. So I'm going to start off talking about RTL SDR. RTL SDR is the core library that everybody uses when they're talking to these dongles. I'm also going to look at a slightly higher level library as well after we've looked at the basics. But if you want to just get the data out of one of these dongles into NumPy arrays or whatever it is, this is the simplest and easiest way to do it. So RTL SDR, you have to install obviously using pip or something like that onto your machine. So I'm importing it, and then I'm instantiating an object called SDR as RTL SDR from the RTL SDR library. So once we've got that, we can then start playing around with it. So there's a whole bunch of, obviously, to use an Americanism, a whole bunch of commands that you can operate. Now, what I'm doing here is setting the frequency of the sample rate itself. I can then set the center frequency, frequency correction. So depending on your your RTL dongle and how much it's off by, you'd have to obviously go away and calibrate that. You can do some calibration stuff with this as well, but I've got a 60 ppm correction factor in there. I've set the gain to auto, which is not typically what you would do, but it works fine for what we're doing here. But obviously you can set the gain on the this is one of the RTLSDR.com ones, one of these metal cased ones, the ones that seem to be around at the moment, and they seem to work very nicely. Then they have got a programmable preamp in them, which has got a variety of settings. Once you've basically configured the device with a few commands like this, what we're doing here is we're reading some samples from it. So this is it's like 200 meg or something, isn't it? I'm not quite sure why I picked that frequency, but I think this was an example that they gave, so I just copied it. So I'm taking 512 samples and I'm dumping them into a object called result, and then I'm closing the SDR. If you you'll find that if you open the SDR multiple times, well, you can't keep opening the SDR. It doesn't like it, so you have to close it and you have to be polite to it. So if we print the result itself, so I'm just going to run this this cell here in my notebook, so we should see the results come out. So there are the results, and of course this is you know, the usual vector imaginary number stuff that that you get out of here we go. This is the Q component, the phase component, which is an imaginary number. So it's not particularly polite or easy to manipulate, but I'm sure any of you that understand how this encoding works, you know that this second value is the Q and this is the P. If you want to, we can run that again with, in fact, I'll get rid of that, all those numbers, and then it makes more room. Let's run that again. So you can see that that's a NumPy array. So it uses NumPy within this library. So once you get it into NumPy as a NumPy array, you can then start to manipulate the results. So that's how easy it is just to read I mean, there's obviously a 512 samples at that frequency. That's all we're getting there. It's an instantaneous reading. So let's extend that slightly by using this product here. This is another library called PyLab. So we can PyLab is actually has been morphed into Matplotlib, to be honest. And in fact, you're not encouraged to use PyLab anymore, but it's basically using Matplotlib. Apparently, PyLab it's lost its favor, and everybody's just doing Matplotlib. But this is just an example again that I wanted to show you. So, in order to plot some values, we're going to do something slightly differently. So we're now in, I think we're in the hydrogen line area now, by the looks of it. We're setting a fixed gain, which is probably more normal. And what we're going to do is read we're going to read 256. Basically, we're reading bins of information here, which we're then going to pass into our plot tool. So that you can make the bin math simpler. We're doing 1024 bins of 256 bytes, and then we're politely closing it. But we're then going to take that value, and this is the PyLab library. So PSD is part of the Matplotlib library, in fact, and it's going to do a fast Fourier transform on it and put some information up about frequency and the power, and then the show command shows it. So let's just run that, and there we go. So that has done an instantaneous FFT on 1024 bins of 256 data points, and drawn the. I don't think that's actually hydrogen alpha. I think that's something in this room, but that's actually real data coming from the dongle. So it is actually doing the thing. So you can see that the code to get the stuff out of these things and to get something on screen is pretty simple. Now the RTL observatory library I found to be a lot more like what you need. So this is somebody has already solved a lot of the maths and problems that you have with doing, certainly for the hydrogen line stuff that I've done with it, they've solved a lot of those problems in this set of libraries, and it's called RTL Obs, which presumably means observatory. So let me just first run this cell that doesn't do anything other than import some objects. So for instance, here we go. This is how you would find the total power. Again, this is all hydrogen line sort of territory. In fact, we've got comments in this one. But the difference here is that we can sample for a period of time. So this one's going to sample for 10 seconds. So it's going to basically integrate hydrogen line sample for 10 seconds and then show us, as it says, an uncalibrated value. And I'll show you how easy calibration is as well. So let's just run that. And of course, what it does is it first of all politely tells you what it's doing, which is quite nice as a return. And then of course you have to wait 10 seconds for it to collect to do its integration. And once it has integrated, you then get the values back. So the uncalibrated total power this is obviously at 2.4. Have we got it at exactly 2.4? We have it exactly. Oh no, it's 1420.4 is what we've got it at. So 1420.4, the total integrated power measurement is that. And of course, again, these are just crazy values. First of all, it's not calibrated, and secondly, on my desk, it's not got a 3-meter dish connected to it collecting photons. So now to calibrate it, very, very simple. This is how you this is an example of for this is working out the cold temperature. So obviously you have to point it at the some cold part of the sky to do that, and I can just run that. It's going to do a 10-second calibration integration on this one. So that's our cold temperature. We can then it uses the technique which is outlined in this link here. I'll put the link in because you know, you can go and find out whether that suits you. I mean, obviously all of these things are up for modification if you want to do your calibrations differently. Assuming that we've done that, I'll use the other measurement as the hot one, as our pointed. I normally, with our dish up at Massam, I just point it. There's a big oak tree right next to our observatory, and I generally point it at the oak tree, and to get the you know, the calibration temperature. And then if we run this cell now, we should end up with our calibration. And did I have that? There we go. So, well, yeah, I mean, obviously you'd be wasting your time if that were if that was your system temperature, but this is all the code you need to calculate that. And this is doing this obviously using this library and NumPy. So all the hard work's been done by the nice man from RTL Observatory. And that's how you get your value. So you can very quickly put a script together to automate all these things, even run them from a GUI. And then ultimately, of course, let's have a look at, now we've got a calibration, even though it's completely bonkers. We can actually now generate an actual spectrum. So this is going to be a 5-second integration, and we're going to have a calibrated spectrum. And we're actually going to save it out as a PNG file for posterity. So let me run that particular one. So here it goes. It's I think it's 5-second integration, and we should have a pretty picture in 5 seconds. There we go. So that's actually now been, as you can see, there's calibration. It's integrated, smoothed, and we've got the value. So had we had a dish on there, it might look a bit more like a, you know, classic sort of pointy bit like that, which would be nice. All labeled up nicely. So, you know, you can see how you can put these very simple blocks together and end up very quickly with some real useful data. And with Simple Gui, you can get all that into a nice Gui as well. I think there's one last example, which is just doing switching power. I'm not really familiar with this technique. I just saw it in one of the examples, and I thought, well, I'd put it in there for people that understand what it's about. But it's something to do with working out noise or something, isn't it? Anyway, you get there's just a different result there. As I say, I didn't really understand that bit. It's beyond my radio knowledge. Or it's a power spectrum estimate. But there you go. But anyway, it's a library which I've found and have been using increasingly. Well, our dish is out of action at the moment, unfortunately, but I've used it with some other data just to cut my teeth on it, and it seems to be really nice. And hoping to do some automation for our telescope when it gets into it's commissioned. Don't know whether Alan's still with us and listening, but we need to get together, Alan, and get that thing sorted. Does that sound familiar to you all? Any questions about the RTL dongle? I mean, there's obviously a lot more you can do with this as a device, but this is just to show you how easy using Python you can get this data out and generate useful data and images very simply.
Yeah, I've got a question, Rupert. You get that characteristic response from RTL dongle of the sort of two wings and then the spike. Does that calibration routine eliminate that? So effectively, you sort of have a constant power baseline against.
Well, if this is connected to a decent dish with a decent feed and your amps are all running properly and your filters are tuned and all the rest of it, you do get much more of a, you do get some bumps at the sides, but you do get much more of a proper reading, especially if it's pointed at the sun or something like that, without a shadow of a doubt.
Experience is using SDR Sharp with the IF average plugin, and that's got quite a nice thing which basically it corrects for that characteristic curve, so it basically removes that.
There are a whole bunch of correction things you can apply in here as well. I haven't really, as I say, our telescope at the moment is not providing us with any data, but when it does, I'm sure I'm going to start tweaking on this fairly heavily. I've only really been playing around with this for a few months just to see how easy it is, because I've been using MIT's software up until now, which is all written in C, and although it works very well, my C isn't up to their C, and it is open source, and you can go in there and you can do stuff, but I just find it horrendously it's pointers to pointers to pointers, and it's just I can't cope. So I'm going to go with Python, because I want our society members to be able to play around with it as well, and they can understand this, whereas you can't if it's written in C. It's just too mind-boggling. So I think there's a lot more that this than I've shown that this RTL observatory software will do than I've shown, but it's definitely worth checking out. And as you can see, it's a bit like falling off a log, really, getting it to work. So that's always good in my book. Because there's so many things to learn in the radio side, the astronomy side, and then the programming side. By the time you've learned all that, your brain's getting fairly full, isn't it?
What's your RTL dongle plugged into? Is it into a PC or is it into a Raspberry Pi?
No, it's a PC. Let me just show you it. Hang on a minute. If I do that, let me just take the camera. It's in a Lenovo laptop, and you can see the dongle there. It's still got the rubber cap on the TNC thing. So that's it. That's my Raspberry Pi next to it, which is, I built it into a box years ago. It's like my prototyping Raspberry Pi 3, and inside that box it's got power supplies and runs on batteries if I need it to, and it's got a touchscreen. Hang on, a touchscreen on the front there, which is going to see, but you can. It's sort of self-contained. I've got it opened up because I've got a GPS in there. In fact, you can see it doing its once a second timestamp on there. So we can have a look at that. Actually, we've got 20 minutes left, so we can have a look at the GPS dongle on a Raspberry Pi just for fun. But yeah, that's my RTL there and my messy desk. Well, one of my many messy desks, I should say. Oops, how are we going? I'll put that back in the middle. There we go. Yeah, so it's a Lenovo laptop running Ubuntu. It's an i5 laptop, nothing special. I have had it working on the Raspberry Pi, but the Raspberry Pi's got a different image on for doing something different at the moment. So that was my original intention, and that's why I thought, well, I'll do a GPS dongle on the Raspberry Pi, because that's another thing that people quite like. They want to use Raspberry Pis in the field, and they want to have accurate time. And if you're away from the internet, that's not necessarily so easy. So these GPS dongles, again, are so inexpensive. You might as well just use those to timestamp your collections. So let's have a look at that. Any questions about that, or we'll go to the Raspberry Pi. Now I can I'm not going to do it. I could do it on the Raspberry Pi itself, but I'm not going to, because I'm going to show you. We can run VNC on a Raspberry Pi, and you can write all the code on the Raspberry Pi if you want. What I'm going to do is show you, again, I'm just trying to introduce you to other stuff you might not be aware of. If we go back to this program here, this is our Visual Studio Code again. In this section here, I've got GPS stuff. Right, so the way that I program Python on my Raspberry Pi these days, and this applies to 0s, 3s, 4s, whatever it is, I use a thing called RMate, which is called Remote VS Code. It's based on a technology called RMate. Now, what is RMate? Well, again, if you go to the extensions in Visual Studio Code and type in remote or RMate, one of the two, it doesn't really matter. Whereas it's in there somewhere anyway. Remote VS Code, there it is. This works for not just Raspberry Pis, but for any remote machine. And what it does is it puts an agent on the Raspberry Pi, which allows you to SSH into the Raspberry Pi. So you can you open an SSH connection, which is the way that you typically control Raspberry Pis, especially if they're headless. So if you're using something like a Pi 0, which is very typically I would use for collecting data in the field, because it's a £10 Raspberry Pi with a complete Linux operating system running on it. Well, it's not to like for £9.95 there. But the thing is that it's quite a small environment. So I tend to run them headless, i.e. without the GUI on there. So it's just the command line. So using SSH to get onto them, to control them, is pretty much the way I would do it. So for instance, if I'm on Windows, I might use putty like this to go on there, and I've got as my Raspberry Pi test set there, and I can just open that up, and there it comes. I can log on and use it that way. Now, if you put this remote VS Code onto your Visual Studio Code, that gives you additional functionality in the respect that if I go to PowerShell, you get PowerShell terminal at the bottom here. You can actually tunnel to your Raspberry Pi that way as well. So this is the command. I put it on the end. I put it the command that you need in my what's it called, Jupyter Notebook, so that you know what to type. So if I type that into the PowerShell in Visual Studio Code, it opens up a connection to my Raspberry Pi. So I just have to log on. There you go. So now I'm actually looking at my Raspberry Pi in Visual Studio. So this is that box that I just showed you over the way. So I can do ls and I can see everything that's on there. I've got a subdirectory for everything we're doing today called RA. So there's the ls command, and we can see there's a couple of files in there. And so I'm actually now able to not only control the Pi, but I can actually start editing the files that are on there. And it uses this SSH tunnel, which is the command that this command here. This sets up your tunnel. So from here, all I have to do is type rmate, which means remotely mate with Visual Studio, and then the whatever it is I want to edit. So if I want to edit, I'm going to be editing this time GPS. So if I do timegps.py and I hit return, if you watch Visual Studio, I've now got that file opened up, and it's now editable in Visual Studio. And I can make changes to that. So if I make a change like that, and if I do save, you'll see it says saving to Raspberry Pi test. And so it's now saved it back onto my Raspberry Pi. So I'm editing it here, but it's actually physically on my Raspberry Pi. It's a really neat way of working, because you can also check this into a Git project as well, and save all your work, all of the changes that you make into a Git repository, as well as having it on the Raspberry Pi. So I just thought I'd show you guys that. So very quickly, let's have a look at this GPS. So the GPS, how do you find where the GPS? Well, the Linux command ls shows you files, but it also shows you devices. If you do ls/dev, you see all the devices that are available to you. Now, GPSs always come up as GPS. So if you do dev/GPS and then a star, it'll show you all the GPSs that are currently connected to your Raspberry Pi. So if I do that, you'll see that I've got one. It's called GPS 0. You can have multiple GPSs if you want. I don't quite know why you'd want that, but you can. So GPS 0 is the device. So all these GPSs pretty much behave like serial interfaces. This one's no exception. So exactly the same library as we used on our Pico, import serial. The port that I'm going to be controlling is exactly what you've just seen me type there. So it's the GPS 0. That's where we're going to open the port. It'll automatically work out what the baud rate is, because I haven't specified. I've just, actually I've specified it, I've lied. So there's our port. Let's go down to this line here. So I'm going to call it SIR, which is shortened for serial. Serial is exactly the same protocol as you saw before. So we've got port, which is our GPS, baud rate 9600 with, again, I've got a half-second timeout on here, which is, remember I described what that was about. So pretty much what you've seen before on the Pico. So while true, data equals serial read line. So every time some data comes in, it starts reading. When it gets to carriage return line feed, because it's the same style of protocol, it will return into data. And then I've written a little routine called parse GPS data, which is this one here. So let's quickly go and look at that. So I'm passing my data into my parse routine. First thing we do, again, is a byte array. I convert it into a string by using decode. If you want to, let's just have a look at that first. Let's do that, and we'll comment all of this out like that. Let's just run this first. So if I do save on here, so that's saved back to here. So all I have to do now is do Python 3, what's it called? Time GPS. So that's how you would run a Python script on the Raspberry Pi. So we just have to physically type that. We haven't got a play button to do it on this one. So we hit that, and there we go. So this is the raw data coming out of the GPS. So it's sending us longitude, latitude, all the whole 9 yards, including the time and lots of other information about, correction and relativity corrections and all the rest of it. We're not really interested in all of that. So let's just break it down very, very simply. And the way to do that, I'm just going to stop that now. that's obviously a recognized protocol and it's readily available, so I won't bore you with all of that detail. But what we're going to do is say GPGGA is the header. If you look at the one of these, there it is, GPGGA. This is the time information here. So that's the one we're interested in. So if GPGGA is in the data, now what I've said is that I could have just put data and it would probably still work, but I've made it a little bit more accurate. And what this 0:6 means is starting from the very first character and going for for 7 characters, 1, 2, 3, 4, 5, 6, and then there's a comma, so up to the 6th character. So what it's saying is that if you can find this in the first 7 characters, then do the following. And what I'm doing is I'm doing what I did in that other thing, is that I'm doing a split. Splits are really handy when you've got information separated by a character, because you can specify what character you want to split them on. What that then gives you is in fact, we've got 6 minutes left, so let me just do this. In fact, I'll copy that onto another line, and we'll do, let me just print out S for the first of all. Let's comment those 2 out and save that, and we'll run this again. So what we should get this time is there we go. So when we do the split, you can see now how that information has changed from, let me stop it. The information, the raw information is comma delimited, can you see here? But now we've split it and we've now got a list of the information. And that's usually the quickest way of getting at what you need, because now your list has got each element and you can index that with a number. So that's what we're going to first of all do. So item number 1 is going to be this one here. Okay, and that is the time, interestingly. So if I save that now, oops, save, and then there we go. Right, oops. Somehow I've managed to lose my P of Python. There we go. So we've now got the time, but it's not in a very nice format. You can see it's 11:20. This is UTC, obviously, 11:24 and 26 seconds. If I go in here, we can improve things there by. So, what first thing I'm going to do is take the first 2 characters and then put a colon. Take the second, well, characters 2 to 4. Or 3 to 4, if you like, the second pair, and then put a colon, and then put the seconds in, and then print it. So I've just basically neatened it up, and we should have. So all I'm doing in here is editing in this section. I'm doing save. I'm doing Control S just for expediency, but you can go in here and do save, and you'll see it says saving to the Raspberry Pi. And then I go back to my Raspberry Pi and then I run my code again. Oh, what's that? Something wrong. Time is equal to, what's it say? Unexpected indent. Oh, yes. That's quite right. Try again. So there we go. And there's the accurate time every second. Now, you have to bear in mind that this is only accurate to on a serial port running at 9600 board, it's accurate to, I don't know, 20 milliseconds or something like that. And it's slightly variable by maybe 5 or 10 milliseconds. So it isn't super accurate. However, all of these dongles, if you buy more expensive GPS boards, they tend to have a PPS, pulse per second, pin on them. And you can connect that to a pin of the Raspberry Pi. And if you with a funky bit of code, you can get the accuracy down to several decimal places. I think theoretically they'll go to about 8 or 9 decimal places just with the pin itself. So in code, you can get the accuracy much better than it is just from this. What my experience is that even the cheapest of these dongles, this one has got an LED that blinks on it every second. But if you open it up, you can see the pin says PPS on it. So I think the accuracy of these is equally good, and you can obviously wire to the back of that LED and bring it into a pin on the Raspberry Pi, and you could increase the accuracy. This might be accurate enough. I don't know what you're trying to do, but sometimes you just need that extra bit. If you're doing meteor, tracking or trying to triangulate meteors, you need as much accuracy as you can, I'm sure. But that's how you get at it. But at least you can get pretty much on the nail the time in the field from a USB GPS, which I bought on eBay for, I think it was £7, something like that. Pretty amazing, isn't it, really? Signals from space for so little money. Well, we've got 2 minutes left, so if we want to finish on time. So I don't know whether you learned anything today. Hope so.
Your GPS dongle, it picks up a satellite signal from sitting inside a case.
Yeah.
Remote from the window.
Yeah.
So, right.
Yeah, as I say, it's only a cheap thing.
Right.
The lid's off. I have run it with the lid on though, and it still works.
Right.
It takes about maybe 2 minutes after you've plugged it in before it starts blasting it out, but it's pretty good.
Is it 3 satellite signals it needs, or
I don't know.
But
probably.
anyway, but
yeah.
Because in the old days you have to stick it outside.
Oh yeah, you'd have to have it. Even if you just put it in the window, it didn't work, did it?
Yeah.
They've obviously come on a lot, haven't they? The sensitivity and noise performance of them is amazing. Yeah. I mean, this is the back of the room, and as you say, it's in a case. It's a plastic case, admittedly, but it's not. You can't see the sky very much. Right, let me.
That's all weather as well, is it? It picks it up in all weather.
Yeah.
Yeah.
Oh yeah, I've never seen it not work.
Right. Good.
I've been running that for a few weeks, just on and off, playing around with it, and it's it's pretty good.
Good.
Let me stop my share and then go back to there. Right. Well, any questions before we round up? As you know, all this code is all available on my GitHub. I will send that link to Paul, and he can send it out to everybody. I'll put it. In fact, it might be worth putting the link to the GitHub on the our BAA site as well, Paul.
Yeah, will do.
Any of you get stuck with Python, give me a shout. I'm only too happy to help as much as I can anyway. Don't bother asking me much about radio or wireless stuff, because even astronomy I'm struggling at, but we try.
Very, very
thank you very much, everybody, for joining me for these 2 sessions, and it's a lovely day today. I know that you'd rather be playing outside.
Yeah, thank you.
Thank you, Rupert. It's been really interesting, and you've covered an enormous amount of ground. You've frightened us with these Python instructions that are needed, but you've given us a brilliant background.
Well, I hope what I wanted to do is try and give you enough tools to make you dangerous, that, being able to do a GUI and control a motor and sample from a 3-meter hydrogen line dish and control it all from Python. If any of you manage to achieve that, let me know, because I'll be very happy. If I can do it, I'll be very happy.
Brilliant.
Excellent, thanks, Ray. That was fantastic.
Thanks for being so patient, and I'll see you all. I'll see you all at a workshop soon.
Yeah, thank you very much, Ru. That was just fantastic.
Yeah. Good. I love that feedback. Thank you, Paul.
Yeah.
Thank you very much.
That was so good.
Yeah. Thank you very much.
Thank you, Rupert.
Bye-bye. Have a nice day.
Bye.
Cheers.